Hello and welcome to this video about velocity, speed and a few other concepts from mechanics. So first have to look at a few definitions. We have a motion from one point to another in some way. Then the distance is defined as the length of the path, whilst displacement equals to the length of the straight line between points. In other words, displacement is this length here, and in some cases we talk about displacement, say it's also have a direction. Then we also have speed versus velocity, and speed is just the magnitude calculated as the distance divided by the time, whilst velocity has magnitude and direction. It's still calculated as the distance over time, but now we need to care about what direction we are moving. And normally for simple problems we are usually just talking about moving along a line, so we have a positive and negative direction. So say we define this as a positive direction and we have some velocity in that direction. Say this is 5 meters per second that direction, or we could have a motion in that direction that is also 5 meters per second, but minus, because it goes in the other direction. So these are different velocities, but it's the same speed. Both of them are 5 meters per second. We also have to remember a few things about some graphs. If we have an ST graph, and then the slope that is calculated as change of S over change of T equals to the velocity. If we have a VT graph, on the other hand, then the slope delta V over delta T equals to, so we say delta V over delta T equals the acceleration A. But this is only, technically speaking, the average over an interval. If we have a constant velocity or a constant change of speed or constant acceleration, these will be straight lines. So here up in the upper figure, if you have a constant velocity, it will be straight line. In the lower one, if you have a constant acceleration, this would be a straight line. But we could have a situation where these are changing. So if we have some graph that is varying like this, then we still say that the slope equals to the velocity, but now S might be some function of t, and we calculate ds dt, in other words, derivative of s with respect to t. That will give us our slope, and that will give us our velocity. And here, if we have a vt graph, same thing. If we want to have acceleration at a certain point, we take the value st v t. We take the derivative of v with respect to t, and that will give us the acceleration a at that particular point. So we can find velocity and acceleration through derivatives. And secondly, in a vt graph, if we look at the area underneath a vt graph, and that will be the displacement. And we can see that since it will, each and every little part of this would be some velocity times some time, and that will be the area. And since we have that change of distance or change of time equals to velocity, then velocity times change of time will be a change of distance or displacement. We have to remember that such graphs, a VT graph, the part of the graph that is above the x-axis, we count these as positive, and underneath this will be negative. So the positive means that you move in one direction, and if velocity is negative, we move in the other direction. And that will, in the first part, if we increase our displacement, then we will decrease it in the second part. So let's take this to a test. We can go down here. I made a graph. So here is a VT graph. We should calculate a few things. What could we find? We could find accelerations at different positions. Let's say we look at this point. What is the acceleration? The acceleration is the slope. So we could actually take the slope of the whole line. So we can see that if we take this, that is 6 seconds, divided by that. So on this point here, we will see that our acceleration is a change of velocity of 6 meters per second over a period of 2 seconds. And that will give us an acceleration of 6 divided by 2 is 3 meters per second. And we have to remember the acceleration has the unit meters per second squared. On the top here, we don't change our velocity at all. So our acceleration is 0 meters per second squared. And along this falling long line here, we'll have that acceleration is, and we can pick 2 points. Say I pick that point and that point. So we go down by minus 2 meters per second over 1 second, and that will give us an acceleration of minus 2 meters per second square. And we can continue like this and see that acceleration on the lowest part down here is 0, and the acceleration here is 4 meters per second square. Secondly, we could be asked about what is the displacement after we have reached this point in time. So after 5, 6, 7, 8, 9, 10, 11, 12, 13 seconds. So we are up to 13 seconds here, right? And we could be asked for what is the displacement or what is the distance traveled. Displacement would be counting the upper part as positive and the lower part as negative, as I said. But we talk about distance traveled, then everything should be counted as positive. So we simply need to find these areas. So we can split this into triangles. The first one is already there. So the first triangle here would be 6 times 2 divided by 2. So that part will be 6 meters. Then we can look at this part. And this part will be yet again 6 meters per second. So this part will be 6 meters per second times 3 seconds. So that will be 18 meters. This part here is now 6 times 3 divided by 2. And that would be 9 meters. So we have the whole first part here. We go up and then go down here. So that whole part, let us call this whole part A. In other words, be 6 plus 18 plus 9. Or 33 meters. Then we can look at the second part here. Let's call that B. We can split that into triangles, rectangles too. So this first part here, 1, 2, 3, 4. Okay, so that would be 4 times 2 divided by 2, or 4 meters. The second part here would be 4 times 2, or 8 meters. And finally, this little part here would be 4 times 1 divided by 2, or 2 meters. We can combine this and say, okay, our part B would be 4 plus 8 plus 2. That would be 14 meters. And what we should do with these two depends if we ask about the displacement or the distance traveled. So say we talk about the displacement. Then we have moved first 33 meters forward, and then we have moved 14 meters backwards, since the velocity was negative in the section B. So that will give us 19 meters all in all. So the object is now 90 meters away from when it started. If we talk about the distance traveled, then we should add these two up. So that would be 33 plus 14 instead. And that would now be 57 meters. Because we travel first 33 meters forward and then 14 meters backwards. All in all, 57 meters. Hope this makes sense. See you next video. In the next video. Oh, need to have a unit there. Ciao.